All right, so remember, each of these postulates or theorem are going to get their own video. So this one we are going to talk about the side angle side similarity theorem. Very similar to what we learned before with the congruent triangles. In side angle side, we still need to have two sides that we're looking at, and the angle that's in between them, or the included angle. So we still need to think of it the same way as we did with congruent, except for now these sides must be proportional, meaning that the ratio of AB over QR, because they are corresponding to each other, AB and QR, must be proportional to the other side, AC and QS. All right, they must have the same ratio, they must be proportional, and if they are, we can then use side angle side to then say that they are in fact similar. All right, so then there's this short video, there's just one example that we're going to go through. Are these triangles similar? If so, write a similarity statement for the triangles. So first off, we know that both of these, the two triangles, let me highlight the one in yellow, and then the other one we'll do in blue. So these two triangles both include this angle K, and since we're looking at the two sides of both of the triangles, we know that if this is going to work, it could be side angle side. That's what we're going to test for. But now, so we know that the angles are congruent, they include an angle, but now we need to see, are the sides proportional? So the first side that we'll look at is the yellow triangle. So the yellow triangle is LK. And then that corresponds to the bigger triangle from this side, and that is MK. So since I put the yellow triangle in my numerator, the next ratio I create, the yellow triangle has to be in the numerator as well. So remember, there's different ways you can do this, but it's all about consistency. So once you set one up, the others have to follow suit. So then our yellow triangle had a side PK, and then our blue triangle had the side NK. All right, now we will just go ahead and plug in what we know. So LK we know is equal to 8. Whereas MK is equal to 8 plus 2, because we need to add these two segments together to get the entire side. PK we know is equal to 12, and NK, same thing as before, we need to add these two sides up, so it's 12 plus 3. All right, then we will just simplify, so it's 8 over 10, and now we're going to ask ourselves, does this equal to 12 over 15? All right, then you can do this one of two ways, and I'll show you both ways. So 8 over 10, does this equal to 12 over 15? The first way that you can do this is you can just simplify each side. 8 over 10 simplifies to 4 over 5. 12 over 15 simplifies to 4 over 5. So since they simplify to the same number, yes, they are proportional. So yes, we know that they are similar by side angle side. Or we know that our cross products, if we want to solve for this, we would cross multiply, so we would say, does 8 times 15, does that equal to 12 times 10? And 8 times 15 is 120, 12 times 10 is 120, so yes. Either way I'm fine with, I don't care which way you use this to show me. You can just simplify, if you find simplifying easier, you can simplify, or you can do the cross products. And now, since we know that they're similar, we can say that we would use side angle side, and then our similarity statement is, it doesn't matter, it doesn't say which triangle we have to go from or to, so you can start which one you want first. So I'll just do the yellow one since we did that in our numerator to begin with. So triangle, and it doesn't matter how you write this first one, so LKP. And then we will say it's similar. And now this is where it does matter. So since I did LK as my first one, MK needs to go for my bigger one, so it's MK, and then the last letter is N. All right, so for this one, you can just match up your two sides that you did, and then the last letter is the remaining letter that you would do. All right, so that's it for this video, and that is it for side angle side. And the last video will be side, side, side.